This video is brought to you by Sporlan, quality, integrity, and tradition.
Well, customer says, all my ACs are down, it's really hot. This one has a blank thermostat. Well, we can only do one thing at a time. So let's start with this one. This one right here has a blank thermostat. So let's open up the electrical and see what's going on inside of here. All right, starting at the disconnect switch right here, let's go ahead and check line 1 to 2, nothing. 2 to 3, nothing. 1 to 3, nothing. So we have no power coming from the breaker downstairs. So let's go ahead and check the fuses to see if maybe we blew a fuse or something. Good. Good. Bad. So we have a blown fuse right here. So let's start with that, and we're going to go to the contactors now, and we're going to check the load side of all the contactors to ground to see if there's any reason for a fuse to blow. Let's go ahead and open this indoor blower section. I already spun the motors. The motors are spinning. So let's open the blower section, look at the blower wheel. All right, we're going to check for direct shorts to ground. What the heck was that? Oh, it's a trash man. Okay, so I'm grounded out right there, and we'll verify that we have a good ground to the ground screw right here. Boom, we're good. Okay, so we're gonna go load side of every contactor. Nothing, 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 nothing. We'll do line side. Check the condenser fan motors. There's no power, no anything. Okay, so no direct shorts to ground causing our problem that we know of, okay? I pulled the belt off. Blower wheel spins. That motor sounds really rough. Sounds like the bearings are shot in it. But we don't know if it's just a loud motor. Let's look in here. I mean, there's a lot of places like that right there can be short. There's a lot, I mean, there's a lot of little nicked wires in there. I hate these carrier units for this reason. Look right in here. There's nicked wires. I mean, there's so many places where we could have a problem. Could be any one of these. All right, well, I'm gonna pull these zip ties and inspect these wires a little bit more. See if we see anything. I don't see anything on the high voltage wires. These are all low voltage, so those aren't gonna cause a main fuse to trip or to blow or go bad or whatever you wanna call it. I ran my fingers down, I don't feel any breaks. Once I cleaned all the dirt off, they don't look bad. So I'm gonna go ahead and re-secure all these wires better than they were, hopefully, and proceed from there. So we're looking for something high voltage. That motor is very suspect because the bearings sound really rough in there. But I don't know if that's the only problem. So we're gonna keep going. The capacitors right here, we'll check these capacitors to make sure they're good. Should probably inspect these contactors too, the covers, I'll pull those off. It's polishing a turd, but got this all separated, zip tied up, ran around so it's not rubbing. We do double zip ties on here, so that way the wires aren't touching the bolt. So that's better than it was. It's not ideal, but carrier doesn't give you a lot of room here. And we may end up having to change this motor too, I don't know. So I'm gonna put the belt on, and then we're gonna proceed to testing the capacitors and then going down and resetting the breaker and changing the fuse and turning it on, really. All right, this disconnect switch, I pulled off the guard, pulled the screws out, and we do have a little discoloration on the right knife. That knife goes up and makes a connection in here. And it doesn't look like we have very good contact in there. In fact, I can see quite a bit of a gap there versus this one that has a really good connection. If you look down here, it's barely making connection on the bottom. So that could be a problem, but we don't know for sure, right? That would coincide with the fuse that's blown. So we look at everything, right? So I need to go get 60 amp fuses, but look at this. The last time I changed these, I left spares, which that's why I love leaving spares, so that way it makes it easier for us next time, okay? So All right, I'm gonna go downstairs, turn this off, change those, I'm gonna start with one fuse. I would change them all normally, but I'm gonna change one just because we might be in a troubleshooting situation. Pulled out the capacitors. This is a 10 microfarad, running right at 10.23. Slightly over, but plus or minus 6. That should be good. And the other one is right at 10 microfarads, so capacitors are good. We'll put those back in there. Last thing, check the contactors, visually inspect them. Don't think it's gonna be a dirty condenser because I can see light through the condenser really well. I don't know how well that comes up on camera, but it's moving through. The contactors all look fairly new. No issues there, no burning, no arcing, no excessive anything. So those look good. I'll put the covers back on. We're getting closer and closer to turning this thing on. You gotta love restaurant electrical rooms. They're always fun to maneuver. And I know everybody's gonna say, oh my God, that's a fire hazard. I know, totally. But every restaurant's like this. It's just ridiculous. So yeah, I gotta maneuver a few things, get this door opened up. There we go. And let's look in here, find our tripped breaker for AC3, 60 amp. There we go, we're back on. We're off on the roof, so we control it from up there. Close this up and head back up top. All right, now, okie dokie, let's go ahead and check voltage. We have the breaker turned back on. 204, 1 to 2. 204, 2 to 3. 205, 1 to 3. So we have proper voltage. What I did for now was disconnect the control voltage for the blower and the compressors so I can control it via the contactors and push things in as I please. So 1, 2, 3, please don't blow up. Okay. Now let's go ahead and check power on the bottom of the fuses. Make sure we didn't blow a fuse. 204. 204. 204. So we're passing power through the fuses now. Now I control it via the contactors. All right, we're gonna start with the indoor blower motor. I've got an amp clamp on the line. Now I know it's gonna overamp right now because I wanna hear the bearings. So let's go ahead and do this. It's running 10 amps, 10.6. You're actually allowed, I think, to run 11. But yeah, that thing's a problem. And look at how it's like it was moving. Let's see this thing. That might be our problem. Starts up rough. Now watch it. Look at the whole motor's like flexing. I'm leaning towards that being our problem. Let's go ahead and just push in the contactors on the compressors. Sounds fine. Sounds fine. Both the compressors sound like they're working. Don't know if pressures are good, but we know it's not a direct short. I'm leaning, look at it. Stuff coming out of the indoor blower assembly too. Stuff dangling. I'm leaning towards this guy being our problem. Heating up as the day goes on. Okay. We're gonna go ahead and shut it off and I'm gonna hook up control voltage and we're gonna go ahead and let this thing start up naturally. Well shoot, look at this. Blue wire. I just saw this right now as I was getting ready. And look right here, blue wire, we're off. Exposed blue wire. Look at that, that thing, look at these guys. They're all eaten up, rubbing on each other. Wow. Those are really bad. Wow, wow, wow. All these wires, they're all just rubbing out on each other. That's a mess. Wow, wow, wow. But yeah, that's something special. So where was that? That was like right here. I don't know if that would have been it because there's nothing for it to really, even though it looks like it rubbed at one point, but I don't know. I don't see anything that it arced against. Definitely have some bare wire, but that doesn't reach that. We need to fix all this stuff. This has just been rubbing its little heart away. But yeah, that's not good. All right, it took me a bit, but I, as best as I could, cleaned up this wiring so there wasn't like tons and tons, and I cut out as much of the messed up wiring, shortened everything. These things are really bad all the way down to the pressure controls. The high voltage, it's not ideal, but I ran it up into here. I don't want to use these wire nuts, but I don't have the right connectors because it's 6 gauge, and these aren't for 6 gauge. These are for 8 gauge. This is for 6 gauge, but you can't fit this on that. It's too big. So I need this size eyelet, but with a 6 gauge connector, which I don't have. So I had to use the wire nuts again, but at least we're not rubbing. I tried to find all the rub out spots as much as I could. I'll inspect these compressor wires really quick. Yeah, so we're just about ready to fire it up, and then I'll probe up too, and we'll test the circuits and refrigeration circuit and all that good stuff. All right, let's hope this doesn't blow up. 1, 2, 3, please don't blow up. Let's see if the indoor blower motor comes on its own. And the indoor blower motor is running at 8 amps. We're allowed to run, I wrote it on here, it's actually 10.2. So we're allowed to run 10.2, so we're not overamping at the moment. The bearings don't sound good, but you know, that's a plus. At this point, this guy has a pretty good vibration. Whole unit shaking, so that could have added to the wires rubbing together. That's going to be the indoor blower assembly, completely out of balance. Yeah, this guy's got a mean vibration to it. All right, well, compressor's not turning on, so I'm going to go ahead and jump it out. I got some jumpers right here. Condenser fan motors are running. One's at 1.93. Let's check the other one. 1.9, and I believe these are allowed to run 2.4, I think. Those are half horsepower condenser fan motors. So we're good. I'm going to put this panel up so that way we can evaluate the pressures. Compressor number 2 is not turned on yet. It's a delay inside the economizer module, so it should turn on here in just a minute. Okay, first stage has been running for about 5 to 6 minutes or so. This is a fixed orifice metering device, R22. We use target superheat to charge. Our target superheat is about 12 degrees right now, based off of the indoor conditions. Subcooling is not, it's not too bad. Head pressure is a little bit on the high side, but not horrible. Saturation temperature is a little bit on the low side according to the indoor air conditions, right? The return air conditions. Superheat is a little bit high. Let's scroll on over. Temperature split on the unit's about 25 degrees. Airflow, something's off about the airflow because this is a 10-ton unit, but let's switch to the second stage because sometimes you get weird readings. According to this, we're putting out 102,000 BTUs. I need to go to the second stage because MeasureQuick does some weird stuff. There you go. Now it's actually showing. So second stage says current value is 132,000 BTUs. We should be about 116, so something's a little off in the airflow there. But let's scroll over here. Airflow is looking a little bit better, saying about 4,000 CFMs is what we should have. We're at about 3,600. You can see when you're on the first stage, it kind of messes the settings up. You need to be on the second stage to see the true settings here. So second stage, let's look at our, we have a 0 degree approach temp. Subcooling's at 30 degrees. Saturation temp's a little bit low on the low side. 116, we're a little bit high on the saturation temp on the high side. Superheat's extremely high on the second stage. This is not a 13 to 16 SEER though. Let's change that. Why is that saying this is a 10 SEER? Oh, there you go. Let's change it. 10 SEER. Maybe that'll help our numbers a little bit. Yeah, that changes our numbers just a little bit. Let's change the second stage, 10 to 12 SEER. There you go. Okay, so I wasn't profiled exactly correct, but we're still a hair low on the saturation temp, but not horrible. Superheat's still high on the first stage. Subcooling's not too bad. Now 23 degrees, that's using discharge pressure. On these carrier units, I typically see about 30 to 35 degree of a drop in pressure from discharge to liquid line because of the fixed orifice metering device and the condenser and all that stuff. So if we were getting a true liquid, that subcooling would be a lower number. Let's go to the second stage. Still kind of running a little bit low on the saturation temp for the low side. Superheat's still really high. I'm not in love with this unit, but it's functioning. I don't doubt that we probably have restrictions in the fixed orifice metering device, which these units are notorious for that. I don't know that I want to put any more refrigerant into it based off of those subcooling numbers. I don't think I want to put any more refrigerant into this guy. Yeah, no, I don't think so. I'm leaning towards, first off, we got some airflow issues, but then also I'm leaning towards restricted metering device is what I'm thinking. But I mean, the unit's functioning. It's not ideal. 26 degree temp split, delivered capacity. I mean, this thing's working, but we need indoor blower assembly rebuild, the whole blower assembly. We need indoor blower motor. To fix the potential restrictions, we would need an evaporator. I don't think the condenser needs to be split. I can see through it. You guys can't see it from this side, but I mean, it's rejecting some serious heat. So this thing's kicking butt. It's doing the best it can for what it is, a turd. So I'm just gonna watch it operate for a little bit. As far as the fuses blowing, I mean, it could have been anything. Could have been the vibration causing that line 3, the blue wire, that had a visible rub out in it. It could have rubbed up against the low voltage 24 volts. It could have rubbed up against something else with the vibration this unit has. The bearings in the indoor blower motor are going bad. That could have been it. And then also, I'm not in love with the disconnect switch, the way it's making connections. So there's a lot of stuff this customer needs to consider with this unit. They really should consider replacing it, considering this is like an 04 unit, I think. Yeah, I think this is an 04. Yeah, I think that's 04 right there. 10-ton 04. So, yeah. All right, well, I'm gonna watch it for a bit longer. Well, I'm back. We still haven't done any permanent repairs to this unit, but we did have another blown fuse, replaced it, and the unit's working. Same issues as before, you know. I fixed all the electrical wiring that I could find with exposed issues, but still don't like the disconnect switch. Still don't like that the blower motor has bearings going bad. But once I replaced the fuse, I turned it on and I was just kind of waiting for a few minutes. And what was interesting was second stage cycled off while I was standing here. And I did have the panel off, so I was like, wait, did it go off on high pressure? Like, it's not that hot yet, it's early in the morning. And then it turned on. And then it turned off again, and then it turned on. And I didn't have a meter on it yet, because it literally just happened after I changed the fuse. And I was like, what the heck? And I'm sitting here thinking, is it going off on high pressure? But then I start thinking, we've got compressor lockout boards. So there's no reason for it to go off on high pressure and turn back on, because the compressor lockout board, essentially, if it has a call for cooling and one of the safeties opens up, or if the compressor contactor doesn't pull in, then there's a current sensing device on that compressor lockout board, and either lack of no current or an open safety, high pressure, low pressure, or freeze stat, this thing should lock itself out and then let us know by sending a signal to the X terminal. So there's no reason for this thing to short cycle on, off, because that's kind of an anti-short cycle protection in a way. So I'm sitting here thinking, either it lost control voltage altogether, but if you look right here, this isn't ideal, but Y1 and Y2 are jumped together. Y1 did not shut off. So that kind of rules out the thermostat, because the thermostat brings power up to this. But coming out of here, it should be going into the economizer, and it has a Jade economizer module. And then it comes out of the module and it comes back over here. But even the Jade module, because we've got Y1 and Y2 jumped together, those, let me see though, wait a minute. Oh, you know what? No, my logic there. But look, even though Y1 and Y2 are jumped together, they're just using the one terminal as a call, but it's still running through the Jade and coming back into the compressor on one terminal. So the Jade could be the problem. There it goes. Lost voltage. It just did it. Wait, and it was when I moved this. So it's losing. Oh, I'm intrigued. It just did it. Why didn't we lock out? Because in theory, we just lost control voltage going to the lockout board. And it didn't lock out. So I was moving these. Was it a coincidence, or is that the problem? Oh, this is an interesting one. And if that happens over and over again, that, in theory, if it's going on, off, on, off, on, off, in theory, that could cause the fuse to blow. But it's a 60 amp fuse and it tripped the breaker downstairs. So this is an interesting one. So when you get these really old units, you know, it can be confusing sometimes, because we know that we've got restrictions in the evaporator. We know that we have an indoor blower motor that's going bad. We know that the disconnect switch isn't working properly, but which one is the problem, or are they all part of it? When they get old, these things get really tricky. So this is interesting. So we lost voltage to the contactor. So the contactor's working correctly. We've got it now, but something happened in the contactor. So try to move, because I was touching these wires when that happened. I'm wondering if it's the Jade module. I really am wondering. We could grab, I bet you it's the Jade module. I really do. Because, again, I'm thinking here, what I should be monitoring, man, I almost need another meter, because I should be monitoring incoming voltage and voltage to the contactor. And then if we have incoming voltage right here, but we don't have voltage to the economizer, that would indicate that the Jade module is potentially the problem. But it could also be doing its job. Oh, that is really interesting. Why is this guy losing connection like that? Huh. I wish I had a tripod set up here. I don't really want to go away because I want to be here when this happens. But I don't think it's a wiring issue, because I've moved these all around. I just think it was coincidence that I was touching them. The first time I was standing over here and I wasn't touching a single thing, and it cycled on and off. Okay, so if we come over here, this guy has a freeze alarm. So it might be doing its job, and it might just have a bad sensor. Let's look at the sensors and see what they say. So we go to status. This is kind of hard. I'll show you guys once I get there. Economizer available, economizing, occupied, cool one. Mixed air temp, 48 degrees. Okay. Outside air, 89. Damper output. So the mixed air temp says it's 48 degrees. Mechanical cooling on. I wonder, set points. I'm gonna go in here. Low lock is 32. Interesting. Okay, I'm gonna play with this a bit. Okay, that's really interesting, because I went into here and I went to recall the alarms and it says no alarms, but it just showed a freeze alarm. I'm wondering if there's something wrong in that Jade module, like if it's malfunctioning. I kind of think it is. That's really interesting. They really need to change this unit. It's just got gremlins in it. And it's not that I'm afraid to fix it, it's that the bill just keeps getting higher and higher. So at this point, for me to walk away from this, indoor blower motor, new evaporator, because both fixed orifice metering devices are restricted, new disconnect switch, new economizer module. And I mean, that's the only known issues, but I'm very suspect of the last compressor. Still has a Carlisle that's just beat down. You could tell it had been overheating. You know, it's still, this thing's just a mess. It's an R22 from 2004. I'll put it. So what I did was I disconnected the economizer module as far as the cooling. We could still open the damper. It still has 24 volts. It'll still give them fresh air, because that's all we use it for, is fresh air basically. I went ahead and wired Y1 and Y2 back in to their respective terminals. So now we're actually going to stage this unit based on calls for cooling. And I'm clamped onto compressor number 2. We're going to watch it for a few minutes, see if it drops out again. But at the rate it was going, the input power going into the compressor lockout board was not being energized, is my assumption, because if not, then the compressor lockout board would have locked it out. Because if it lost, yeah, essentially it was like the thermostat was turning off the compressor, I think that's what was happening. Again, it's hard to say.
I can only do what the customer lets me do, and if they don't approve my repairs, then, you know, can't do anything. So they haven't approved my repairs yet. And, you know, who knows? We're giving them a quote for a new unit too. So we'll give them both options, you know, and say this is what it is. Here's the thing. A lot of people don't understand this. Here in California, it is ridiculously expensive to change equipment. First off, the equipment is insanely expensive. I'm in Southern California. But then on top of that, the loopholes and stuff they have to jump through with permits and all that stuff, it's usually a nightmare. And a lot of the times, depending on the customer, it just depends on the customer, you know. A lot of times they want to fix the equipment, and this would be really expensive to fix. And I'm borderline thinking they should change that other compressor too, but I guess it's still working, you know. So I didn't quote it with the other Carlisle compressor because they already have a newer Copeland for the second stage. But, you know, I can only do what the customer allows me to do. So in this situation, I think that economizer module is part of the problem too. I think that's the main problem. I'm wondering if that thing was just turning on and off, because there was no reason for it to turn off. But you guys saw my process, right? You guys see me working on all this equipment. A lot of it's the same type of equipment, but I still go through the troubleshooting process, because especially the older the equipment gets, the more gremlins it can have in it, the more weird problems, you know. We found a bunch of rubbed out wires. You know, the contactors were all good, but the disconnect's not making good connection. That's another hot ticket item on these things, you know. Indoor blower motor's making noise. You know, so all I can do is just give the customer all the information and let them make an informed decision. And I just have to be happy with the decision that they make. So if they tell me to fix it, I'll fix it. I'll be fine, you know. We'll go back, though, with R22. My personal experience on these units with fixed orifice metering devices is your best bet is to stay with R22. I tend to notice some issues when you use like 407C on these things. So I've just been happier with R22. If it's got a TXV in it, 407C, as long as we have polyester oil in the compressor, I'll be a happy camper. Now, this one, the newer compressor that is installed on this unit would be polyester oil, but the older compressor is still going to be mineral oil. So that is not compatible with 407C. I know there's people out there that say that they do it and it works just fine. You're not me. I'm not doing that, okay? I'm going to do things the right way, and, you know, my customers support that. So all I can do is just wait for them to give me the approval to do whatever it is that they want me to do. I really appreciate you making it to the end. Thank you so very much. It's been a crazy, crazy summer. Do me a favor, if you haven't already, please consider subscribing to the channel. Share this channel with friends, people that you think would enjoy this content, technicians, young technicians, whatever it may be. If you think that this benefits them in some way, share it. Share the heck out of it. I try not to spam people too much. I try not to like go out and just share my channel all over the place, just e-begging people, you know. I'll say it in the videos every once in a while, you know, hey, subscribe, share the channel kind of a thing. But that's it. I'm trying not to push this too much. I don't want to bombard people and annoy them like crazy, you know. I've kind of calmed down with sharing on Facebook and stuff just because I don't want to be a burden to people. I share occasionally in some groups, but that's it. Just a few select groups. So yeah, please consider subscribing to the channel if you haven't already. Go check out my website too, hvacrvideos.com. We have merchandise available. That's actually where you can find this hat or a dad hat, flat bill hat. They're all black underbills. This one right here is the standard flex fit hat. This is a breathable material. You can actually see light through it when you look up in the light, but it's not a trucker hat. It's just a very active wear. You sweat the minimal amount with this hat on, you know, and that was the whole way I designed this hat. I put a lot of effort into it, and you notice there's not a lot of craziness going on with this hat. It's pretty simple. The acronym on there, HVACR, that was intentional instead of having a giant logo and stuff, because I wanted you guys to potentially be able to wear this without violating uniform policy. That's the idea. So some people can, some people can't. But again, HVACRvideos.com. Now, if you want to support this channel, you know, the easiest way to support this channel is literally just watch these videos from beginning to end. That really is the easiest way. A couple other ways. Obviously, my website I already mentioned. You can go to PayPal or Patreon, HVACR videos on all social media platforms, including PayPal and Patreon. But there's links in the show notes of this video for PayPal and Patreon. And YouTube channel membership. Sorry, I forgot that one. That's the other membership thing that you can choose. There's links for all three of those. Last but not least, you can go to TrueTechTools.com. If you see me using tools in my videos, a good majority of the time I've gotten them from TrueTechTools.com. The job link probes in this video that I used to probe up on the system was all from TrueTechTools.com. I have an affiliate program set up with them, so if you use my offer code BIGPICTURE, one word, at checkout on majority of the items on their website, you'll get an 8% discount, and then I get a small commission from that. So it's a great way to help support the channel. You get a discount. They got lots of great stuff there. They are really good people over at True Tech Tools, so really awesome. Go give them a chance. If you find something you like on there, just be sure to use my offer code BIGPICTURE. Again, thank you so very much. I really do appreciate you, and we will catch you on the next one.